Hello everyone, and welcome back to my channel. In today's video, we'll continue from where we left off in example 8, where I discuss the process of converting a 2D orthographic view into a 3D isometric view using third-angle projection. If you haven't watched the previous video yet, I highly recommend checking it out to get up to speed. Today, we'll dive deeper into the process and make it even easier for you to understand. So, grab your drawing tools, and let's get started. To analyze the given orthographic views effectively, we must carefully examine the details presented in both the front view and the left side view. This analysis will help us visualize the three-dimensional object represented by these two-dimensional projections. Starting with the front view, we observe that the total width of the object is 7 mm. Within this width, there are two distinct rectangular features, each measuring 2 mm in width and 7 mm in height. These rectangles are positioned adjacent to each other, contributing a total of 4 mm to the overall width. This leaves us with 3 mm, which likely accommodates the tapered feature known as the sheaf of horn. This sheaf begins at the bottom of the object and extends upward to the center, with a width of 3 mm at its widest point. This tapering design adds a unique characteristic to the object, suggesting a functional or aesthetic purpose. Next, we turn our attention to the left side view. Here, we find that the depth and height of the object are both 7 mm, reinforcing the notion that we are dealing with a cubic structure. A notable feature in this view is a hidden horizontal line, located at the center, precisely 3.5 mm from the bottom. Additionally, there is an inclined line that begins to millimeters from one corner of the 7 mm by 7 mm square and extends to connect with the upper corner. This inclined line suggests the presence of a sloped surface or an inclined plane, further enhancing the complexity of the object's design. From our detailed analysis of both views, we can conclude that the object is fundamentally a cube with dimensions of 7 mm by 7 mm. However, it is important to note the additional features which contribute to its overall structure and functionality. Understanding these elements is crucial for visualizing the object in 3 dimensions and for any potential applications in design or engineering. To set up the isometric axes for drawing, we need to establish a clear framework that will guide us in accurately representing the three-dimensional object based on the orthographic views we have analyzed. In isometric drawing, the axes are oriented in a specific manner to maintain the correct proportions and angles. First, we begin with the vertical axis, which represents the height of the object. This axis will be drawn straight up from the base of drawing area, indicating how tall the object is. In our case, the height is 7 mm, as derived from the orthographic views. Next, we need to establish the 30-degree axes. These axes will represent the depth and width of the object. The axis that extends to the right of the vertical axis will represent the depth, while the axis that extends to the front will represent the width. Both of these axes should be drawn at a 30-degree angle from the horizontal line, which is crucial for maintaining the isometric perspective. When drawing these axes, it is important to use a ruler and a protractor to ensure accuracy. Lightly sketch the lines so that they can be adjusted if necessary. Additionally, make sure that all axes are equally scaled. Since we have determined that the dimensions of the object are 7 mm for depth, 7 mm for height, and 7 mm for width, you will measure and mark these lengths along their respective axes. Before we begin constructing the isometric box based on the established isometric axes, it is essential to first determine the front side position of the object. This selection is not merely a formality. It plays a critical role in how we will visualize the object in three-dimensional space. The orientation we choose will dictate which face of the object is emphasized as the front, influencing the overall perception of its shape and features. In our specific drawing, the object possesses unique characteristics, including a tapered surface and inclined planes on both the right and left sides. To effectively showcase these features, we must select the appropriate side of the axis, specifically the x-axis, as the front. By doing so, we ensure that both the tapered surface and the inclined planes are visible in the isometric view. If we were to choose a different orientation, we might miss the opportunity to observe both features simultaneously, which would detract from the clarity and effectiveness of our representation. As we previously discussed, the object we are working with has distinct characteristics, including a tapered surface and inclined planes on both the right and left sides. To effectively highlight these features in our isometric drawing, it is essential to select the appropriate side of the axis. Specifically, we will designate the x-axis as the front. This choice allows us to present the object in a way that emphasizes its unique design elements. Once we have established the front side, we should focus on creating the inclined feature first. Referring to the left side view, we observe that the inclined line begins to millimeters from the ground along the y-axis and rises upward to one corner of the square, which measures 7 millimeters by 7 millimeters. If either of these axes were employed, the inclined line would transform into a plane, altering our perception of the feature. However, since we are not utilizing the z-axis or the x-axis for this particular line, we conceptually recognize that it represents an inclined plane, which can be observed from both the front and top views. We noticed as shapes labeled B and C. The question arises, which of these represents the inclined shape? If you answered B, you are correct. This is because the inclined line is not dashed, which is typically used to indicate hidden lines. The fact that we see shape B from the left view suggests that it was drawn first. As we mentioned earlier, we are now creating a 3D isometric view. To achieve this, we will utilize two of the three axes. In the case of the inclined line, we will employ the x-axis to establish its width, which measures to millimeters from the front side view. This approach allows us to accurately represent the object's dimensions and features in the isometric perspective, ensuring that the inclined line is properly visualized within the overall structure of the drawing. The x-axis line is not visible from the left side view because the x-axis lines are perpendicular to the line of sight in that direction. In contrast, the y and z-axes are not perpendicular, making them visible from the left side. As previously mentioned, the x-axis line is not visible from the left side view. The inclined plane is drawn using both the x-axis line and the inclined line. When the x-axis line is removed since it is perpendicular to the left side view, the resulting view takes this form. Consequently, the shape to be drawn from the left side view is the upper rectangular-like figure. Additionally, there is a hidden line that is horizontal and positioned at the center of the left side view, indicating that this horizontal line is not visible from that perspective. The remaining shape on the front side is as shown because we initially created a 2 mm by 7 mm rectangle. However, a question may arise. At what position should this shape be placed at the starting plane? In the middle? Or at the end? The answer can be determined by examining the left side view. When observing the hidden line, it extends straight along the depth, indicating that the extrusion of the shape begins at the outer plane and concludes at the end plane. Therefore, the shape should be created accordingly. And that's it for today's tutorial. We've successfully converted the 2D orthographic view into a 3D isometric view, building on what we covered in example 8. I hope this step-by-step guide made the process clear and easy to follow. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more technical drawing tutorials. Feel free to drop any questions or suggestions in the comments section below. Thanks for watching, and I'll see you in the next video. Happy drawing!